In this video, I will show you how to calculate the volume using cross-sections. Find the volumes of the solids whose bases are bounded by the graphs of y equals x plus 1 and y equals x squared minus 1, with the indicated cross-sections taken perpendicular to the x-axis. For part A, the cross-sections will be squares. I am about to draw a version of the xy plane as seen directly from overhead. Y equals x plus 1 is a line with a y-intercept of 1 and a slope of 1. Y equals x squared minus 1 is an upward-facing parabola with its vertex at 0, -1. This yellow region is the base of a three-dimensional solid coming directly out of the screen at you. In order to calculate the volume of that solid, we need to know the intersection points of the blue curve and the red curve. So let's set the two curves equal to each other and solve for x. If we subtract x from both sides of the equation, we have x squared minus x. If we subtract 1 from both sides of the equation, we have minus 2 equals 0. This trinomial is probably factorable, so let's give that a try. X squared will only factor as x times x, and 2 will only factor as 1 times 2. To get a middle term of -1x, we need x plus 1 and x minus 2. Using the zero product property, we have x is equal to -1 and x is equal to positive 2. So these are the x coordinates of the intersection points. Picture a strange loaf of bread sitting on this base. If you slice the bread perpendicular to the x-axis, each slice is actually a square. Finding the volume of the loaf is a three-step process. Step 1 is to find an expression for the base of each slice. So this thin purple line, picture it as the bottom of a slice. Here, I'm going to draw that same base in the 3D image. So this is the bottom of the slice. We need an expression for the length of that. Let's call this purple length lowercase b for the base of a slice. The length of the base will be the top function minus the bottom function. So this length will be x plus 1 minus x squared minus 1. Distributing the negative sign gives us this. Now let's just rewrite this in the proper order. So we will have negative x squared plus x, and then 1 plus 1 is 2. So this is an expression for the length of the base of a slice. Step 2 is to find an expression for the area of each slice. In this case, each slice is a square with base b. So the area will be b squared. But we already have an expression for b. So that means the area will be this trinomial squared. So negative x squared plus x plus 2 squared. Step 3 is to calculate the volume of the loaf by integrating the area. Essentially, we are adding up all of the slices between -1 and 2. So we will integrate from -1 to 2. In order to integrate this trinomial squared, we need to expand this expression. So a trinomial squared is just a trinomial times a trinomial. So I am going to do the distributive property 3 times. First, I am going to distribute negative x squared across the other trinomial. So that gives me this. Next, I will distribute the x across the trinomial. That gives me this. Notice how I line up my like terms. Finally, I distribute the 2 across the trinomial. That gives me this. Now I'm just going to combine all my like terms. So we get this. Let's substitute this polynomial back into the integral. Now let's integrate term by term. Increasing the first exponent by 1, I have x to the 5th power. Dividing by the new exponent, I have 1/5 in the front of that term. Next, I will take my x to the 3rd power and make it into x to the 4th power. Dividing -2 by 4, I get -1/2. Next term, x squared becomes x to the 3rd power. Dividing -3 by 3 gives me -1. Next term, x becomes x squared. Dividing 4 by 2 gives me 2. And 4 becomes 4x. We are integrating from -1 to 2. So I'm going to take this entire expression and apply the limits of integration. This tells me that I need to take the value at 2 minus the value at -1. It doesn't quite fit on the screen, but here's the value at 2 minus the value at -1. Applying all of the exponents gives me this and this. Doing all of the multiplication gives us this. Combining all of the whole numbers gives us this, well, integers. Getting rid of the brackets and distributing this negative sign gives us this. Making like denominators gives us this. So the volume of the solid is 81/10, which equals 8.1. For part B, we are using the same base of the three-dimensional solid. So a lot of the work has already been done. In fact, step 1 has already been done. The base of the slice is still B. The only difference is that the slice is not a square anymore. So for step 2, when we calculate the area of a slice, it's a rectangle that has a height of 1. So the area of a rectangle is base times height. So the area of each slice is going to be this trinomial times 1, which is just this trinomial. So I guess the base and the area are the same expression. So that's step 2. It's time for the final step where we calculate the volume by integrating the area, essentially adding up a bunch of slices from -1 to +2. So we will integrate the slices, the areas, from -1 to 2. This is going to be a lot easier because we don't have to expand this or anything. So we can begin integrating term by term right now. So let's start with the first term. The x squared will become x to the 3rd power. We divide by the new exponent by putting a 1/3 in the front. And this term is negative. Next term, we increase the exponent to x squared. We divide by the new exponent, so 1/2. And the 2 becomes an antiderivative of 2x. We evaluate using the limits of integration from -1 to 2, which means we need to find the value at 2 minus the value at -1. So here is the value at 2 minus the value at -1. Applying all of the exponents gives us this. Doing all of the multiplication gives us this. Getting rid of the brackets and distributing the negative sign gives us this. Combining -8/3 and -1/3 gives us -9/3. Adding 2 plus 4 plus 2 gives us 8. And I just brought down the negative 1/2. But wait a minute, negative 9/3 is just negative 3. Making like denominators gives us this, so the volume of the solid is 9/2. For the last 4 problems, the solid has a new base. Find the volumes of the solids whose bases are bounded by the circle x squared plus y squared equals 4, with the indicated cross sections taken perpendicular to the x-axis. Here is a view of the base of the solid as we look down directly from overhead. The equation x squared plus y squared equals 4 is a circle centered at the origin with a radius of 2. In order to calculate the volume, we will be taking slices of the solid that are perpendicular to the x-axis, and for this problem, each slice is in the shape of a square. So there are 3 steps to finding the volume of the solid. Step 1 is to write an expression for the base of each slice. Let's take the equation x squared plus y squared equals 4 and solve for y so that we have an expression for x that we can integrate later. Subtracting x squared from both sides, we have y squared is equal to 4 minus x squared. If we then take the square root of both sides of the equation, we have y is equal to plus or minus the square root of 4 minus x squared. This is really 2 separate equations. We have y equals positive square root of 4 minus x squared, and we have y equals negative square root of 4 minus x squared. This is important because we have one equation for the top half of the circle, that's positive square root of 4 minus x squared, and we have another equation for the bottom half of the circle, that's the negative square root of 4 minus x squared. We can use this information to find an expression for the length of this purple segment, which represents b, the length of the base of a single slice. This length will be the top curve minus the bottom curve. So it will be positive square root of 4 minus x squared minus negative square root of 4 minus x squared. But this is the same as the square root of 4 minus x squared plus the square root of 4 minus x squared. So we have our expression for the length of the base of each slice, 2 times the square root of 4 minus x squared. That's step 1. Step 2 is to write an expression for the area of each slice. Keep in mind this is a square. If the base is b, then the area will be b squared. So let's take our b and square it. So if we square the 2, we get 4. And if we square the radical goes away. And we end up with 4 minus x squared. Distributing the 4, we get the area is equal to 16 minus 4x squared. And that's the end of step 2. The third step is to find the volume by adding up all of the slices by integrating the area. So we will integrate 16 minus 4x squared with respect to x, and we are adding up all of the slices from negative 2 to positive 2. So we will integrate from negative 2 to positive 2. The antiderivative of 16 is 16x. Now, the antiderivative of negative 4x squared, we increase the exponent by 1, so we have x to the third power. Then we divide by the new exponent, so we end up with negative 4 over 3. We need to evaluate this using the limits of integration. So we need to find the value from -2 to +2. This means we need to find the value at 2 minus the value at -2. So here's the value at 2 minus the value at -2. Applying the exponents, we have this. Performing the multiplication, we have this. Getting rid of the brackets and distributing this negative sign gives us this, which simplifies to this. With like denominators, we have this. So the volume of the solid is 128 divided by 3. By the way, if this were a free response question, you should leave your answer in this form, just in case you might make a careless mistake in the simplification process. For the next problem, the base of the solid is the same circle as before. So the base of each slice will still be the same expression as before. So step 1 is already finished. Step 2 is to find the area of each slice, or an expression for the area of each slice. But this time, instead of squares, each slice will be in the shape of an equilateral triangle. So, given the base B, we need to figure out an expression for the area of an equilateral triangle. Here is an equilateral triangle with base B. So really all three sides have length B. We need to find an expression for the area. The area of a triangle is 1/2 base times height. We have the base B. We need to calculate the height. When we draw the height like this in green, the right-hand side of the triangle is a right triangle. The bottom of this right triangle is half of the base. So we have 1/2 B. The hypotenuse of the right triangle is B because it was an equilateral triangle. All three sides are B. And then we have the height. So let's set up the Pythagorean theorem. It'll be h squared plus 1/2 b squared is equal to b squared. Leg squared plus leg squared is equal to the hypotenuse squared. We need to solve this for the height. So let's see, I have height squared plus 1/2 squared is 1/4. So I have 1/4 b squared is equal to b squared. Let us subtract 1/4 b squared from both sides. So I'm going to have h squared is equal to b squared minus 1/4 b squared. But these are like terms. B squared, this is like 1b squared. This is like having 4 over 4 b squared. So I have h squared is equal to 4b squared over 4 minus 1b squared over 4 is 3b squared over 4, or 3/4 b squared. So if I take the square root of both sides, I get h is equal to the square root of 3 over 2b. Okay, so I've recorded that off to the side. Remember, we are trying to find an expression for the area of this triangle in terms of b. And this will be 1/2 base times height. I don't really need this part anymore. So it's just 1/2 base times height. So that's going to be 1/2 b, and then the height is the square root of 3 over 2 times b. So I'm going to say times the square root of 3 over 2b. If I simplify this down a little bit, the 1/2 times the square root of 3 over 2 becomes the square root of 3 over 4. And b times b is b squared. So that took a little bit of time to come up with this expression. If you wanted to memorize that when you have an equilateral triangle with base b, the area will be the square root of 3 over 4b squared, that would save you some time. Otherwise, you have to go through this whole process each time. So some of these come up over and over again, like an equilateral triangle, a semicircle, a square, things like that. So as you see these, memorize as many of them as you can. Anyway, we're not quite finished yet. We have a equals the square root of 3 over 4b squared, but we have this purple expression for b. Let's go ahead and substitute that in. So the area will be the square root of 3 over 4, and then b squared is going to be 2 times the square root of 4 minus x squared. Okay, that's our b. And then now this is b squared. Let's keep going. So I have my square root of 3 over 4. If I square the 2, I get 4. If I square the radical goes away, and I just have 4 minus x squared. I don't feel like putting 2 sets of parentheses, so I'll just do it like this. Notice that these 4's cancel each other out. So an expression for the area of each slice will be the square root of 3 times 4 minus x squared. And that's the end of step 2. Step 3 is to find the volume by integrating the area. Basically, we are adding up all of the slices from -2 to +2. So that's why we will integrate the area from -2 to +2. On the next step, I will take this constant of radical 3 and put it in the front of the integral. As I integrate, I will leave the radical 3 out in the front. So the antiderivative of 4 is 4x. And the antiderivative of x squared is x to the 3rd power with a 1/3 in the front. And we need to evaluate from -2 to +2. This means we need to find the value at 2 minus the value at -2. So here we have the value at 2 minus the value at -2. Applying the exponents, we have this. Performing the multiplication gives us this. Getting rid of the brackets and distributing this negative sign gives us this. Combining some of the terms gives us this. Making like denominators gives us this, which simplifies to this. So the volume of the solid is 32 radical 3 over 3. However, if you have a free response question on the AP exam, I strongly encourage you to leave your answer like this so you don't risk losing points for careless mistakes. For part C, we are still using the same circle as the base of the solid. So our expression B for the length of the base of a single slice remains the same. So step 1 is done. Step 2 is to find an expression for the area of each slice. But for part C, each slice is a semicircle. So we have a semicircle where the diameter is length b. We know that the formula for the area of a circle is pi r squared. So half of a circle will be 1/2 pi r squared. Well, r is the radius. In this case, the length of the entire diameter is b. The radius will be half that. So the radius is 1/2 b. That gives us 1/2 pi times 1/2 b squared. if you square 1/2, you get 1/4. So we have 1/2 pi times 1/4 b squared. 1/2 times 1/4 is 1/8. So we have 1/8 pi b squared. 1/8 pi is the same thing as pi over 8. So we have pi over 8 b squared. This is an expression for the area of a semicircle with diameter b. And that's what we were looking for. So we have the area of each slice is pi over 8 b squared. So if you don't want to have to go through this every time, you might want to memorize that a semicircle slice with base b has this area. Otherwise, you have to go through this every time. So memorize as many of these as you can, and this is a very common one. Anyway, we have an expression for b, so let's go ahead and substitute 2 times the square root of 4 minus x squared in for b. That will give us a is equal to pi over 8 times 2 square root 4 minus x squared squared. So the area will be pi over 8. And if we square the 2, we get a 4. If we square the radical goes away. And we have this. The 4 goes into 8 twice. So this will become area equals pi over 2 times 4 minus x squared. So that's the end of step 2. The last step is to find the volume of the solid by adding up all of these slices of area. We can do that by integrating the area from -2 to +2. On my next step, I will put the constant of pi over 2 out in the front. As we integrate, we will leave the pi over 2 way out in the front. Let's integrate term by term. The antiderivative of 4 is 4x. And then I see the x squared. I'm going to turn that into x to the 3rd power and divide by the new exponent. So I will have a 1/3 here. And then this is negative. We have the limits of integration. So we need to integrate from -2 to 2. This means we need to find the value at 2 minus the value at -2. Here's the value at 2 minus the value at -2. After we apply the exponents, we have this. After we do all of the multiplication, we have this. Taking away the brackets and distributing this negative sign gives us this. Combining some of the like terms gives us this. Making like denominators gives us this. Subtracting these fractions gives us this. 2 goes into 32 16 times. So the volume of the solid is 16 pi over 3. However, if this is a free response question on the AP exam, I advise you to leave your answer in this form. For part D, we are still using the same circle as the base of the solid. That means the length of each slice, called B, will still be 2 times the square root of 4 minus x squared. Step 2 is to find an expression for the area of each slice. However, this time, each slice is in the shape of an isosceles right triangle. In other words, a 45, 45, 90 triangle. So here we have this isosceles right triangle. The hypotenuse is face down. That's length B, which is the length of a single slice of this solid. I'm going to use the Pythagorean Theorem to write all three sides in terms of b. So I have n squared plus n squared is equal to b squared. If I add these two together, that gives me 2n squared is equal to b squared. Dividing both sides by 2, I have n squared is equal to 1/2 b squared. If I take the square root of both sides, I get n is equal to 1 over the square root of 2 b. I'll go one step further and write n is equal to b over radical 2. Don't forget that our goal is to be able to find an expression for the area of this triangle. So I've rotated the triangle to make it easier to calculate the area. However, instead of n, let's put b over the square root of 2. We know that the area of a triangle is 1/2 base times height. Well, the base of this triangle is b over radical 2, and the height is also b over radical 2. So 1/2 base times height will be 1/2 b over radical 2 times b over radical 2. So that's going to give us a is equal to b squared over, and radical 2 times radical 2 is 2. And then we still have this 2. In other words, a is b squared over 4. Actually, I think I'd rather write this as 1/4 b squared. So here is another fact to memorize if you don't want to have to go through this every time you run into an isosceles right triangle in this type of a problem. An expression for the area of an isosceles right triangle face down with base b is a equals 1/4 b squared. If you memorize this, you won't have to do all of those calculations next time. Anyway, we have an expression for b though, so let's substitute 2 times the square root of 4 minus x squared in for b. And we get a is equal to 1/4 times 2 times the square root of 4 minus x squared squared. So we have 1/4, and when you square the 2, you get 4. When you square the radical goes away. And the 4's cancel each other out. So the area is just 4 minus x squared. So that's the end of step 2. The third step is to find the volume of the solid by adding up all of these slices of area. We do that by integrating the area from -2 to +2. The antiderivative of 4 is 4x. The x squared will become x to the third power, and then I divide by the new exponent by writing a 1/3 in the front. We need to integrate using the limits of integration, so from -2 to +2. This means we need to find the value at 2 minus the value at -2. Let's take a shortcut here. We just did this on the previous problem. We integrated from -2 to +2, 4 minus x squared dx. And that part of it came out to be 32 over 3. So let's use that now. So this is simply going to be 32 over 3. So that is the volume of the solid.